So my name's Ryan. I'm from the University of Leeds in the UK, and my research is all about programming as a musical performance. We call that live coding. And I do that using Python, and I'm going to talk to you today about why, how, and what it's all about. I'll basically answer the questions that most people have when I tell them I'm a live coder, and the first one is usually, what on earth is live coding? And then once I tell them, they usually think I'm kind of crazy and say, why do you do that? So I've got an answer prepared for that one, and then once I answer that, hopefully you'll be interested enough to wonder how you yourself can do it at home. And then I'll do a bit of a demo, you can see what it's all about, and hopefully have some time for questions at the end. So yeah, what is live coding? So here's a quote from a website called toplap.org, and that's an organization that's dedicated to the promotion of live algorithmic performance. And the quote goes like this: "Live coding is a new direction in electronic music and video, and it's getting somewhere interesting. Live coders expose and rewire the innards of software while it generates improvised music." So what does that mean, really? Well, it's using code to describe rules for generating music. It can also be used to generate visuals, or even as choreography for dancers, or other things we've not even thought of yet, but today I'll just talk about music. I like to think of it as sort of like a live notation for music, kind of like composition, but as a performance. Usually composers will work on a piece weeks, months before it's actually performed. You're actually composing it while it's being performed. In contrast to traditional software engineering, or what we sometimes refer to as dead coding, you're interacting with code while the program you're writing is running. So rather than having that sort of, writing your program, saving it, and possibly compiling it, deploying it, running it, what have you, it's all happening at the same time. And you kind of have this feedback loop, this creative feedback loop where you are changing your code, running some of it, listening to the output generated, and then reacting. And that might be changing something, might be taking something out, adding something new, and then this feedback loop just kind of continues until you decide to end the performance. And that's, in a nutshell, what live coding is all about. And the thing I really like about it is that it makes computer programming a social activity. I don't know if many of you program for other people. Maybe you do it as like a team or for work, but you're often by yourself at your screen, and it's kind of a solitary experience, whereas this brings people together to listen to music that you're programming. So here's some people live coding, some images of people live coding. And as you can see, behind them all, you can see the screen being projected, and that's a really big part of the practice. So there's a manifesto that the Toplap website came up with when it was, coming up with the idea of what live coding should be, and a big part of it is show us your screens. And that might just be because, one, it stops people from, just pressing play on something they pre-recorded and then just checking the emails, but it also gives the audience a kind of access into what's going on, like the process, because it's a bit of a weird thing, someone just typing at a laptop and music coming out. It sort of shows the audience what's going on. Although people get quite intrigued by it and actually just sort of stand there going, oh, yeah, oh, rather than actually listening and dancing to the music, which is a bit strange. So in recent years, it's gained some popularity, a lot in thanks to something called the algorave movement. And algorave is basically algorithmic music to try and dance to. Algorave is kind of a stupid name, but it stuck, so that's what we use. And it's kind of good that it's stupid. I think it shows that we don't take ourselves too seriously. Sometimes computer music comes off as this sort of thing people do by themselves in a dark room with headphones, listening to bleeps and bloops going, This is about people having a bit of a party, using algorithms to make music. And this has been happening for the best part of 2 decades, since about 2001. And there've been events all over the world. It's quite popular in Japan, South America, and a bit in Europe. Who knows, maybe in the Czech Republic sometime soon. And it celebrates improvisation in performance. So you'll often start with like a blank screen, start typing and music will generate, and yeah, you kind of start from nothing and you come up with a performance for people, and then you finish, at the end of it, you delete everything. So it's not your typical programming experience. So why would someone want to actually do live coding? Well, why would we want to use code for music? Well, we already use code for music in a way. This is sheet music. That's the kind of Western classical music, what we can identify as a sheet music, and that is encoding information, things like pitch, duration, loudness. That's all being encoded in here, which is then interpreted by humans to then act on an instrument to make music. Using computer code is quite flexible. It's not very limiting. You're sort of only limited by your own ideas. It's also, you're not limited by user interface. So where a user interface only gives you certain options, with writing a program, you can kind of hack the language a little bit, write your own functions that do what you want it to do, which is a really nice way to make music. I really like it because it's kind of like, as I mentioned before, composing as performance and getting to interact with your composition while it's being performed. You might just come up with something on the fly and be able to just work with this idea in front of people and enjoy that for what it is. Another big thing for me is that I get to operate on what I call the cutting edge of liveness. So what do I mean by live? So here is a sort of diagram with some images of people listening to or creating music. And I think they're all music, but we can all agree that these are different forms of live. So on one end, we have some guy listening to music through a stereo that's been recorded months or even years before, and it's being reproduced through speakers. That definitely isn't live. Then slightly more live than that might be a DJ set where the music's all been pre-recorded, but it's being performed by the DJ, who then sort of handles some of the levels and things. So the music was created, but on its way out the speakers, it's being adjusted. Maybe a bit more live than that are pop singers who sing along to a backing track. So like Katy Perry, for example, will sing live, but the music she's singing to has already been recorded. So it's kind of a mix of live and not live. A lot of people then think of classical music, or the kind of orchestral music, being live. It's being performed. There's no amplification. It's just people making music right there in front of them. And I agree that is live music. But I think you can actually go further into what is more live with things like jazz, where music's being made up on the spot. These orchestras are playing pieces of music composed hundreds of years ago, and there's actually quite a big delay between that musical idea and it being acted upon, whereas in jazz, the music idea and the action are almost at the same time. And that's kind of where I think live coding is, and it lets me just think as performance, really. So it's all about being in a moment, listening, reacting, and putting my musical thoughts onto, well, not really paper, into my text editor, and creating music. But that means there's an element of risk, because I'm doing it all live. It's not being pre-planned. Things can go wrong. You can get errors. There's no quality assurance. You're not unit testing your code or anything. You can get system crashes, which is actually when you get the biggest cheer of the night. It's kind of like when punk rock stars will smash their guitars on stage. If you crash your code, that's kind of what you're doing. And it showcases a high level of virtuosity. If you're able to get up there and make something up on the spot that's enjoyable, that's a bit more impressive than someone who maybe memorized something and wrote it out, I guess. So the music is being generated in real time by the computer, but it's the thinking which is kind of the live part for me, and that's why I like to do it. So, how does one go about live coding? So there's lots of different examples of live coding languages. Just like there are lots of different programming languages, there's many languages that have been adapted to live code with. So SuperCollider, I should mention, which is a really important language in the history of live coding. A lot of other languages use that because it's not only a language but also contains an audio engine. So the other two languages on here, Tidal Cycles and Sonic Pi, also use it to create sound. Tidal cycles is based in Haskell, so it's a functional programming language where you're looking at kind of combining functions of patterns of numbers to create rhythms and pitches. And actually, it was used by, I can't remember what band it was, 65 Days of Static, to compose music for No Man's Sky, a video game which used like algorithmically generated planets, and the music was in part algorithmically generated too, which is pretty cool. People who have a Raspberry Pi at home might have come across Sonic Pi before. That's based in Ruby, and that's developed to help teach kids how to code by making them code music. But I feel like you have to do quite a lot of typing to get not much sound out. So I wanted to develop a language that was flexible, easy to write, and used Python because I really like Python. So yeah, for me, I wanted to create a live coding environment that really focused on the object-oriented side of things. I wanted to be able to access states of certain things. So if I had a melody going on somewhere, I could access that melody and do something with it. And also, I wanted these kind of relationships to be dynamic. So if I changed that melody that's being referenced by this other thing going on here, that would also change along with it. The focus was also on musical patterns as opposed to digital signal processing. So I didn't have to, do anything in C because kind of signal processing is actually quite hard and requires quite fast language. So Python is ideal for just working with the patterns. And yeah, I also wanted it to have a clean syntax. One, to be easy to write for people who maybe aren't good programmers necessarily. It might be new to programming as well as music, but also be easy to read for the audience. Because there's this sort of like barrier when you project your code. It might mean absolutely nothing to someone, but if it's a bit more easily read, they might be able to sort of understand the relationship between the code and the music. So here's sort of like a system diagram of what FoxDot does. FoxDot is just a Python library that you can use in your own projects or anything, excuse me. But it also comes with an editor which you can live code with written in tkinter. But you can use other editors like Atom or Emacs, things like that. You can configure it that way. So FoxDot handles all the sort of musical events, like the timing for things that happen, these states of these sort of music-making objects, which I mentioned before, time-dependent variables. Because when you're programming music live, you're sort of programming in time. Time is passing while you're writing your code, and you want things to change, because in music, well, without change, it gets pretty boring. So you want variables that will maybe change their state over time. And also pattern grammars for creating patterns in music, because that's kind of inherently related to music. So it does all this and then sends messages via Open Sound Control to Super Collider, which I mentioned a few slides ago, and that handles all this sort of audio processing and sending it out to your speakers, which you hear as music. So here is the kind of a screenshot from a typical live coding session with FoxDot. It looks a little bit different to a typical Python programming session. So I'll go through some of the key aspects of it and explain what they are. So these variables, these two-character variables, P1, B1, P2, that sort of thing, these are all instantiated at runtime to save you having to create them before you get playing. So you don't have to go P1 equals player and then use it. It just means it just saves typing, which when you're performing for people, you want to do. And these are the objects that actually generate the music. You give them instructions, and they start to follow these instructions. So it uses the double greater than symbol syntax, which is usually for bit shift, but it's not really being used here. So you give it a name of like an instrument, or what we call a synth definition, and then you call that instrument and give it some instructions, and these will be sequences. So the first argument will be a list of numbers for pitch, and then keyword arguments for other different things like duration or filters for how the sound effects. There's also a special sample player synth-def called play, which instead of taking a sequence of numbers for pitch, it takes a string of characters, and each character relates to a sound file on your computer. So that string gets parsed, and you can use brackets to do interesting things with that strings. Is that 50 minutes plus the Q&A, sorry? Okay. Yeah, so different brackets will do different things. So square brackets will play a few things in quick succession. Round brackets will alternate which sound is being played. And curly braces will play a sound at random if you want to add more variety to your sequence. I mentioned patterns. So patterns are kind of just like container types, a bit like lists, but work a bit more similar to NumPy arrays if you've used NumPy. So adding two patterns together will sort of add each value in turn rather than appending them onto the other one. And these also come with useful methods for manipulating order and things like that, such as palindrome. So if I did, pattern.palindrome, it would append the reverse of that pattern onto the end of it, things like that, which is useful for making music because, as I said, patterns are just everywhere in music. And there's also predefined functions for generating useful patterns of numbers. For example, a function called pdir, which I use a lot for generating rhythm. It just takes two numbers to create interesting rhythms. Time-dependent variables, like I said, you want things to change over time, otherwise music gets quite boring. So this var object essentially defines a sequence of numbers or objects, basically, which it will hold as state for a duration of time. So the first argument is your sequence of different objects, and the second argument is the duration. So here it's going to hold the value of 0, 1, 2, then 3 for 8 beats at a time. So when the time in the clock is 0, and you print the value of chords, it'll just return a 0. After 8 beats, it'll change to 1, then 2, then 3, and then once you get round to 32 beats, it'll go back to 0 and just keep cycling. So it's really useful for making chord sequences and things like that. So player states, yeah. So I mentioned accessing player states and being able to use them in different places. You can do things like follow another player. So this bottom line, the piano line, is going to follow B1, which is a bass. So it's going to accompany that by adding a chord on top of it. And you can also affect these states using this every method. So every 4 beats, it's going to call the reverse method on it. Reverse it just uses the getAttra function to look up the method and will raise an error if it's not found. And you can also reference things like the pitch or amplitude duration by just using like the dot, like p1.pitch will return the pitch, and I can add 2 to it. So this second player pads will always play 2 steps in the scale above the pitch of P1. And if I change P1 pitch, then P2 will automatically update because it's a dynamic object, which is quite nice. So all these events, when they're, all the timing is handled by this clock object, which kind of schedules all the musical events. We can also schedule any callable object, like a function, to happen in the future, for example. And a cool thing you can do with live coding is that you can write a function which then calls itself in the future, and then you can change the function while it's being called. That's kind of how the player objects work. They will essentially call themselves, update their state, play the current note, and then schedule themselves the next duration into the future. So that kind of covers FoxDot, really. But I think the easiest thing to do is actually demonstrate how it works rather than just going through each thing. So I'm going to do a demo, and hopefully we get some sound. OK, so I press Control and Enter, and a line will flash red, and that means the code's being run. So hopefully, OK, and by default, it will just repeat until I tell it to stop. So I can give it some pitches to just, so there's 0 and 4, it just plays 2 notes on repeat. Now it's quite boring, so I'll change the duration a bit. Use this pdir function, which I really like to use. I'll change the sustain, so the notes are a bit longer. And I might do something like every 3 beats, call a method called offAdd, which will add 2, on the off beat, it'll play a note 2 steps higher in the scale. So, okay, that sounds good. And then maybe every 5 beats, I'll call stutter, So I will stutter it 4 times, play the same note 4 times across 3 beats, but in the octave above. So. Okay, that's, alright. So it sounds kind of organic. It's just these very simple, 1 line of code, and it sounds like this kind of someone's just sort of, playing around. Just gonna add a little effect to make it kind of sound cooler. Okay. And I might add sort of like a kind of background ambient thing just to sort of sit behind everything. And then we'll add some percussion, some drums or something, just to sort of carry the whole thing. Let's add some chords behind it. Okay, I'll shut up for a bit and just focus so I can actually make some nice music for you guys. Wow, thank you so much. I didn't even have to do a system crash. That was good. Yeah, so if you want to find out more about live coding in general, toplap.org is a good place. It's kind of like a blog where people post things that they're doing and like events going on, see if there's anything that might be near you. Algorave.com, again, lots of links to different artists who make this sort of music, although Algorave is more kind of techno and house and things like that. That was quite a happy, nice piece. I thought everyone might need a bit of a lift at the end of the day. If you want to find out about FoxDot itself, you can go to foxdot.org, and that's got installation instructions and things like that. So tomorrow I'm doing a workshop, like an intro to FoxDot. You can find out how to install some of the software you need on there if you want to come along to that. There's also a kind of Slack-like chat room community at a website called talk.lurk.org, and that's got channels for FoxDot and other live coding environments. Yeah, or if you can email me, ryan@foxdot.org, or check out my GitHub. If you maybe don't go on my GitHub because the back of the code is actually really horrible. But anyway, thank you so much for listening. Thanks.
Thank you very much, Ryan. If you don't mind taking some questions.
Yeah, of course.
There is one that actually the moderator had to cancel a few copies of this one. Will the live coding be part of the after party?
I think it will. I think we've got to double check a few things, but quite possibly, yeah, which should be fun. Yeah.
Thank you. How long did it take you to get to this level of live coding proficiency?
So I've been doing this since 2015, so nearly about 3 years. But they say, like, there's kind of like a saying that to be, a master of anything, you've got to put in about 10,000 hours worth of practice. And actually, no one has, no live coder has really done that much live coding yet. So actually, the ceiling's still there to be pushed. And, a lot of what I was doing was kind of not very good and stuff, so I was quite slow in the way I sort of got up to skill, and a lot of it was developing this language to make it easier. So hopefully it means people who then use it can then, catch up pretty easily. Yeah.
Do we have questions from the audience? I have one.
Sure.
So how much music theory do I need to understand the relationships within those numbers?
I mean, it helps, I guess, because I come from a bit of a music background, but I play in a live coding group, actually. So my research is about collaboration in live coding, and I play with a group, and one of them, she's a drummer and doesn't know anything about music theory, and actually some of the stuff she makes, kind of just experimenting with different values, is really cool and stuff I wouldn't maybe think of. So I think sometimes coming at it with a music theory background limits you a bit. You're a bit stuck in one mind, whereas if you come with it maybe just wanting to experiment, you can find something cool. So.
Thanks. What advantage does FoxDot bring to people that already use Super Collider? The syntax looks similar.
Yeah, so I guess, the syntax is heavily based on Super Collider. It's just trying to make it as terse as possible, really, trying to make it, one, easily readable. I guess the main thing was syntax, but things like playing sound files, like samples, is kind of tricky. You've got to do a lot of work yourself to be able to load them up. This sort of does all of it for you, basically. I'm quite realistically thinking that people who want to progress and make more, interesting music might well use FoxDot as a stepping stone to using Super Collider, because there's more flexibility. This is really about just trying to make music quickly and easily, where Super Collider, very flexible, very powerful, but it can be quite a barrier to entry. So hopefully, yeah, it can lead the way into it, I guess.
Thanks. On what platforms does FoxDot work?
So Super Collider is a tricky one. So Super Collider works pretty well on Windows and pretty well on Mac, but I think installing it on Linux can be tricky. I think sometimes you have to install it from source, which is a little bit fiddly for some people. But FoxDot itself, as a Python library, works on all platforms, and Python 2 and 3, provided I've tested everything properly.
Thanks. What do the abbreviations VST and DAW mean? Do you know?
DAW is Digital Audio Workstation, which is kind of like, if you've seen Ableton or people like Audacity, programs like that, where you record and you have like sound files that you can like highlight the sound, like the audio waveform, and do stuff and digitally alter it that way. VST, I think, is like plugins for digital audio. That guy knows. Virtual Studio Technology. Yeah, if you want to know, I'd ask the tech guys. They probably know more about that.
Can I buy your live coding CD somewhere?
I don't have a CD or anything, but I have a SoundCloud. SoundCloud.com/Kirky. It's like spelled like quirky, but without a U. QIRKY. I think I might plan to release like an album maybe next year, but right now I'm still trying to hone my sound, I guess, and sort of figure out what kind of music I want to make. Right now, focusing a lot on the software development, but hopefully, yeah, this coming year, really focus on the music more. Yeah.
Have you ever tried playing together with real quote-unquote instruments like the electric guitar?
Not with a guitarist. I did play a bit with a drummer for a while, but he moved away, which was sad, so we didn't jam anymore. But I know some people who do. I know some people who think drumming is quite popular to provide rhythm and then sort of to create like a sort of synthy backdrop. And I've seen some people do electric guitars. I think if you YouTube Sam Aaron, he does some stuff with people using electric guitars. But yeah, people are always trying to find new ways to push live coding in different directions and try and make it more accessible. And for some people, that's introducing live instruments. I know, yeah, lots of different things you can use, and there's always possibilities for further collaborations. So,
thanks. In terms of workflow, could you compare LMMS versus live coding?
What's LMMS? I'm not familiar with the term, unfortunately. Fruity Loops. Oh, okay. I guess, so I haven't used Fruity Loops, but I think it's taking like drum loops and stuff and putting them together. Okay. You can do the similar sort of things in live coding. I like live coding because I can interact on it sort of like a musical notation level, and I can write music in a way. I don't know if you can do that in Fruity Loops, but I like having that sort of control using text, just being able to really put my thoughts down in a programmatic way to create music. But yeah, people make music in all sorts of different ways. I'm not saying this is for absolutely everyone, but I think people who enjoy programming and are able to think logically might find it like an enjoyable way to approach making music.
Just a note, not a question. Recent versions of Super Collider are possible to compile on Linux, and most multimedia repos for distros contain it, which is a good news for me because I'm coming to your workshop tomorrow.
Awesome, that's awesome. Yeah, I didn't realize that.
By the way, there's a workshop tomorrow, and there are still a few open spaces on there, so you can register for the workshop. Just heard that from another organizer here.
Cool. Thanks. I'll see you there.
Do you have any classic background in music? Just a short answer, please.
Yeah, I mean, I used to play in an indie rock and roll band when I was like a teenager. I thought I was like the best band in the world for like, a year. And yeah, so I knew a bit about writing songs and stuff, but then when I went to university to learn about music, I realized I kind of knew nothing. And it's been a really great experience to learn more about different ways of making music. But yeah, I have a bit of a background, but not like classical, I suppose.
And we're over time, but let's finish. Is it possible to use it as a MIDI instrument?
You can go, yeah, probably. So you can connect to MIDI devices kind of via FoxDot to Super Collider to a MIDI device. And working on doing MIDI in, which could then probably connect with a DAW. So yeah, always looking for ideas and things like that. So that's a possibility. Yeah.
Right. Thank you, Ryan.
Cheers.